Somewhere in the night sky, about 3,000 light-years away, a star system is building toward an explosion.
Not a Hollywood explosion, a real one.
And when it happens, people on Earth may look up and suddenly see a new star appear in the sky with the naked eye. It could shine bright enough to be noticed by millions of people.
But here's the strange part. This star has done it before, and astronomers believe it is preparing to do it again.
Its name is T Coronae Borealis, also known as the Blaze Star.
And right now, scientists around the world are watching it closely, because sometime soon, this hidden star system could erupt and light up Earth's night sky. NASA describes T Coronae Borealis as a star system about 3,000 light-years away that may become visible to the unaided eye during a rare nova event.
Part 1. The star you can't see. Yet. Most nights, T Coronae Borealis is invisible to the human eye. It sits in the constellation Coronae Borealis, also called the Northern Crown.
To most people, this part of the sky looks ordinary, quiet, empty. But hidden there is a cosmic time bomb. Normally, the blaze star is too faint to see without strong binoculars or a telescope. But during its eruption, it could brighten dramatically from around magnitude 10 to around magnitude 2, making it visible to the naked eye. That means a star that is normally hidden could suddenly appear, as if someone switched on a new point of light in the sky.
And for a short time, Earth would have a visitor from deep space, a star that was always there, but suddenly bright enough for everyone to see.
Part 2. This is not a supernova. When people hear star explosion, they usually imagine a supernova. A massive star reaches the end of its life, its core collapses, and the explosion becomes so powerful it can outshine an entire galaxy.
But T Coronae Borealis is different. This is not a supernova. This is a nova. A nova is still explosive, but the star system survives. In fact, T Coronae Borealis has erupted before and will likely erupt again. That is why astronomers call it a recurrent nova.
It repeats again and again, about every 80 years. The last major outburst happened in 1946. Before that, another was observed in 1866. NASA has described this as a rare, once-in-a-lifetime viewing opportunity because the outburst cycle is roughly 80 years.
So if this eruption happens soon, it will not just be another astronomy story. It may be the first time in a lifetime that billions of people are alive for this exact event.
Part 3. The two-star system. The blaze star is not just one star. It is a binary system. Two stars locked together by gravity. One is a red giant, an old, swollen star near the end of its life. The other is a white dwarf, a dense stellar remnant, about the size of Earth, but with a mass close to that of a star. The white dwarf is small, but it is incredibly powerful. Its gravity pulls gas away from the red giant. That stolen gas forms a hot, swirling disk around the white dwarf. Slowly, material piles up on the white dwarf's surface, layer after layer, year after year, decade after decade, until the pressure and temperature become extreme. Then suddenly, the surface ignites. NASA's visualization team describes T Coronae Borealis as a system where a red giant and a white dwarf orbit each other, with gas from the red giant forming an accretion disk around the white dwarf before flowing onto its surface. This is the moment astronomers are waiting for, a thermonuclear eruption on the surface of a dead star. Not strong enough to destroy the system, but bright enough to make it suddenly visible from Earth. Part 4. The star that keeps coming back. Most stars do not give us a schedule. They change over millions or billions of years. But T Coronae Borealis is unusual because history gives astronomers a clue. It erupted in 1866, then again in 1946. That gap is about 80 years. Now another 80-year window has arrived. That is why astronomers are paying attention. But space does not run on human calendars. The star does not explode because we expect it to. It erupts when the physics inside the system reaches the breaking point, and predicting the exact moment is extremely difficult. Some early predictions expected the nova to occur in 2024, but as of recent monitoring, the eruption has not yet been observed. Current public skywatching updates still describe astronomers as waiting for the event. That uncertainty makes it even more exciting, because the blaze star could erupt while you are asleep. It could happen while you are walking outside. It could happen while telescopes around the world are pointed somewhere else. And when it happens, the clock starts ticking, because this cosmic light show will not last forever. Part 5. What will we see from Earth? If T Coronae Borealis erupts, it will not look like a giant fireball spreading across the sky. It will not burn the atmosphere. It will not harm Earth. It is far too distant. Instead, it will appear as a bright new star, a point of light. But that point of light will represent a thermonuclear explosion happening thousands of light years away. For a few days, it may be visible without a telescope. With binoculars, it may be visible for longer. Then slowly it will fade. The new star will vanish back into darkness, and the system will begin preparing for the next eruption decades in the future. Think about that. A star that is normally hidden from the human eye could briefly join the visible sky, then disappear again for another generation.
Part 6. Why scientists care. To most people, this sounds like a beautiful sky event, but to scientists, it is much more. This is a chance to study a nova eruption in real time.
Modern telescopes can observe light across many wavelengths: visible light, ultraviolet, X-rays, gamma rays, radio waves. Each type of light reveals something different about the explosion: how the material moves, how hot it gets, how the white dwarf reacts, how the red giant feeds it, and whether this cycle could someday lead to something even more violent. Some white dwarfs in binary systems can eventually become unstable enough to explode as type A supernovae. Those supernovae are important because astronomers use them to measure cosmic distances. They helped reveal that the expansion of the universe is accelerating. So, a small hidden star in the Northern Crown may help scientists understand some of the biggest mysteries in the universe.
Part 7. How to find it. When the blaze star erupts, people in much of the Northern Hemisphere may be able to look for it in the constellation Corona Borealis. The constellation sits between Bootes and Hercules. One common method is to find the Big Dipper. Follow the curve of its handle to the bright star Arcturus. From there, look toward the small arc-shaped constellation Corona Borealis. That is where the blaze star will appear. The best viewing months are generally spring through summer for many northern observers, and public skywatching guides identify March through August as a strong visibility window.
But the most important thing is this: when astronomers confirm the eruption, do not wait too long. The star may only be bright for a short time. This is not like a planet that stays visible for months. It is more like a cosmic flare, a sudden message from deep space, and then it fades.
Part 8. The light we see is ancient. Here is the part that makes this even stranger. T Coronae Borealis is about 3,000 light-years away. That means the light from its eruption will take about 3,000 years to reach Earth. So when we finally see the explosion, it will not be happening right now from the star's point of view. It will have happened thousands of years ago.
The light has simply been crossing the galaxy all this time, traveling through darkness, past dust clouds, past other stars, across a distance so huge the human mind can barely hold it.
And one night, that ancient light may finally arrive here, in your sky, above your home, visible with your own eyes.
Part 9. The human side of the event. Imagine people in 1946 looking up and seeing this star brighten. That was a completely different world. No smartphones, no social media, no live streams, No global telescope networks connected instantly online.
Now, imagine it happening today. The moment the blaze star erupts, alerts will spread across the world. Astronomers will rush to gather data. Amateur skywatchers will point cameras toward the northern crown.
People will step outside their homes and search for a new light in the sky. For a few nights, humanity will share the same cosmic event, not through a screen, but by looking up.
That is what makes this special. It is not just science. It is a reminder that the sky is alive. The universe is not frozen.
Stars are changing. Systems are evolving. Explosions are traveling toward us as light. And sometimes, the universe gives us a rare chance to witness something that only appears once in a lifetime.
Somewhere in the constellation Corona Borealis, a silent star system is waiting. A red giant is feeding a white dwarf. Gas is building. Pressure is rising. And when the moment comes, a hidden star may suddenly blaze into view. It will not destroy Earth. It will not light up the sky like the sun. But it may create something just as powerful in another way, a shared moment of wonder. A star that disappeared for generations could soon return. And when it does, the whole world may look up, because the blaze star is coming back, and this time, we are ready to watch.